So for number 10, you need 3 points to plot. Now, how do we know what kind of x values to propose? You may say 0, 1, and 2, and when you propose it, just go ahead, think about this. Put the proposed numbers into x and think about, if I put 0 in there, what would it be? If I put 1 in there, what would it be? If I put 2 there, what would it be? And you realize that, okay, that seems like a pretty good number to work with, and then you can finalize your suggestion. So you say, all right, x equals to 0, 1, and 2. And x equals to 0, 1, and 2. So when x is 0, so you simply have 3 to the second power, which is 9. So somewhere right there, 0, 9. All right, so even though it's not really on the graphic area, it doesn't mean that the y-intercept doesn't exist. Okay, you still write down 0, 9. And then you have 3 to the 2 minus 1 power, which is 3 to the first power, which is 3. So 1, 3. And then you put in 2 into x, you have 3 to the 0 power, which is 1. Okay. There is no shift of any kind vertically. Therefore, the asymptote will remain at y equal to 0. And you may now go ahead, connect the dots. Okay. Is it a growth or decay? Totally a decay. Okay, it's getting smaller over time. Domain and range. Very obvious from the graph. Just make sure that you're reading the graph, or what you're writing for domain and range actually matches with the with what it's expressed by the graph. Yes. Okay, how do I find the asymptotes for any exponential function? By default, it's going to be y equal to 0. And the idea behind it is that if you have a number, in this case 3 raised to any number, it has to be greater than 0. There's no way to be 0. There's no way to be negative. So that's why we say, yeah, the asymptote is y equal to 0, because as you can see here, if x becomes bigger, if you actually like put a calculator out and then plug in some x values, it will be a very small number, but it's still a number bigger than 0. Okay. So that's why we say by default it is y equal to 0.